Hello, ib3 higher level students. Let's start our next video lesson. Today I'm going to focus on November 18 session. This is November, so just one time zone. Paper 2. One of you asked me about solutions for exercises 3, 4, 6, 8 and 9. Exercise number 3 and exercise number 4 both are exactly the same for higher level and for standard level student. What does it mean? It means that you can find solution for these two exercises in previous video. Lesson 1 I've solved all November 2018 paper 2 for standard level students. Okay? So let's focus on exercise number 6, 7, 8 and 9. I hope that you try to do this. If not, please stop video. Open this paper, November 18, paper 2 physics time zone 0, and try to solve exercise number 6. Okay, when you will be ready, turn it again and let's solve it. Okay, so exercise number 6. State how the density of nucleus varies with the number of nucleons in the nucleus. Okay, so let's look. In your data booklet here, you have equation linking number of nucleons in the nucleus with a radius. Okay, so R is R0 constant, A to the power of 1 over 3. Is it clear? Okay, so what does it mean? It means that the nucleus has a bigger radius if there are more nucleons in the nucleus. So how to find density? Density is a mass over volume. Okay, mass is related with number of nucleons in the nucleus. We can assume that each nucleus has a mass of approximately 1 unit divided by volume of the sphere, 4 over 3 pi radius to the power of 3. What is important? Important is that radius to the power of 3 is constant R0 to the power of 3 times A. What does it mean? It means that A cancels. And density of the nucleus doesn't depend on the A. Is this clear? So when density doesn't depend on the A, it means that all nuclei have the same density. So this is the answer. Density doesn't depend on the mass number. Is it clear? Okay. Second, show that the nuclear radius of phosphorus is about 4 femtometers. Okay, you have to take this equation. Yes? Okay, A in phosphorus is equal to 31. R0 is a constant. This is Fermi radius, which is somewhere in data booklet, probably on the page with constants. No, this is not data booklet, sorry. Exercise number 6. Okay, and data booklet is here. So at the very beginning we have constants. Okay, R0, 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 1.2 times 10 to the power of minus 15 Fermi radius. So you have to substitute 1.2 times 10 to the power of minus 15 of meters, substitute, and you have solution. Okay? B. P32, phosphorus 32, is found when a nucleus of deuterium collides with nucleus of phosphorus 31. The radius of deuterium nucleus is 1.5 femtometers. State the maximum distance between the centers of the nuclei for which the production of P32 is likely to occur. So remember that radius is the range of strong nuclear force. So if you have a phosphorus of given radius, which was calculated in previous, and deuterium of given radius, okay, so to absorb deuterium or to connect deuterium by phosphorus, you have to add these two radii. Okay, so if distance between these two particles will be less than sum of radius of phosphorus and radius of deuterium, then strong nuclear force will be bigger than electrostatic repulsion, and deuterium will be absorbed or connected to phosphorium. Is it clear? Next, determine in joules the minimum initial kinetic energy that deuterium nucleus must have in order to produce phosphorium. Assume that the phosphorus nucleus is stationary through the interaction and that only electrostatic forces act. And so minimum initial kinetic energy that the deuterium nucleus must have in order to produce phosphorium. So we have again phosphorium of this isotope of 31. Okay. With 15 neutrons and hydrogen 2, so deuterium. The question is about minimum initial kinetic energy, okay, to create phosphorium of 32. So let's look. You have to refer to this. Molecules must be at distance which is shorter than the radius of phosphorium plus radius of deuterium. So you have to find electric potential energy between these two particles at this distance. Electric potential energy is K. Q1, so phosphorium has 50 E. Q2, so deuterium has 1 E, divided by distance, where distance is radius of phosphorium plus radius of deuterium. Okay, so kinetic energy minimum kinetic energy to reduce distance to r must be equal electric potential energy between these two particles. Okay, next. Phosphorium 32 goes beta minus decay. Explain with the energy gained by the emitted beta particles in this decay is not the same for every beta particle. Okay, remember in this case you have to refer to the fact that beta minus decay occurs only if electrons antineutrino is emitted. So energy which is released in beta minus decay, total energy is shared between electron, beta minus, and between electrons antineutrino. Is it clear? So when energy is shared, not always energy of beta minus particle is the same. So you have to refer here to the existence or production of electrons antineutrino. Okay, what is meant by a decay constant? B. Okay, decay constant has definition. Do you remember? Nuclear decay is one where rate of decay is proportional to the number of particles. Okay, of course, the number of particles is reduced during decay, so there is a negative, and decay constant is a coefficient of proportionality. So the best description is the coefficient of proportionality between the rate of decay and number of particles ready to decay. Okay, in fresh pure sample of phosphorium 32, the activity of the sample is 24 becquerels. After 1 week, the activity is 17. Calculate the decay constant. So not difficult. You have to refer to this equation. At the beginning, we have 24. After 1 week, we have how much? 17. Okay, and time is 1 week. So 1 week must be converted into seconds because the question is about decay constant expressed in second to the power of minus 1. So we have to convert time 1 week into seconds, substitute and calculate lambda. Okay, and how this? Okay, in my opinion, not bad. In my opinion, easy. Please, if you have print version of November 18 paper, please write these answers. Of course, you can move your movie back, our movie back. I think all is clear. Of course, make calculations. I didn't do calculations. You know that my Casio is broken and doesn't work. So this is why I didn't do calculations. Yes, I know I can calculate in my mind, but let's try to do this. Okay, so next exercise you've asked is exercise number 8. Okay, exercise number 8, higher level. There is a proposal to place a satellite in orbit around planet Mars. Let me switch a slide. Okay, exercise number 8. And it was also 9a. I must write because I will forget. Okay, so let's back to 8. There is a proposal to place a satellite in orbit around planet Mars. Outlined what is meant by gravitational field strength at the point. Gravitational field strength is gravitational force acting on unit point test mass. Newton's law of gravitation applies to point mass, suggest why the law can be applied to a satellite orbiting Mars. Because let's again Newton's satellite orbiting the Mars behaves as a point mass. So each object has something which is called a center of mass. Okay, so Newton's law, which works for point masses, means that it can be used for every object of every shape if you will calculate distance to the something which is called center of mass. So you have to refer to the center of mass here. B. The satellite is to have an orbital time t equal to the length of day on Mars. It can be shown that blah blah blah, where r is the orbital radius of the satellite and k is the constant. Mars has a given mass. Show that the Mars k is about 9 times 10 to the power of minus 13. Okay, so here you have third Kepler's law. T squared, this is B? Yes, B. T squared is equal constant times radius of the orbit to the power of 3. Okay, and we know that we have a Mars and we have a satellite. Okay, this is radius of the orbit. We know that satellite orbits. And what do we have? We have mass of Mars, 6.4 times 10 to the power of 23. In standard units. And that's all. You have to find k. Okay. So let's look. To find k, except you have to know t squared and r to the power of 3, or you can derive third Kepler's law and check what the k is. So let's do this. So Kepler's third law can be derived by equation Fg, gravitational force, equals Fc, centripetal force. So G, mass of Mars, mass of satellite, orbital radius to the power of 2 is equal mv squared over r. You can cross, of course, mass. It doesn't depend on the mass of the satellite, and 1r. And, of course, you have to know that v is equal 2 pi r over t. Is it clear? So finally you can write g times m over r is equal to v squared. So 4 pi squared r squared t squared, obtaining gmt squared equals 4 pi squared r to the power of 3, or t squared is equal 4 pi squared divided by g m r to the power of 3. Here it's written that t squared is equal to k times r to the power of 3, so k is equal to 4 pi squared over g m. So m is given, g is a constant, 4 pi squared is a constant, so you can calculate k, and it should be 9 times 10 to the power of minus 13. Okay? Next, the time taken for Mars to revolve on its axis is 8.9 times 10 to the power of 4 seconds. Calculate in meters per second the orbital speed of the satellite. The time taken for Mars to revolve on its axis. Okay, so there should be somewhere information about the type of satellite. Is geostationary or not? Because in other case this constant is not, this value is not needed. So let me check details. Okay, it's written. The satellite is to have an orbital time equal to the length of day on Mars. What does it mean? It means that this is geosynchronous satellite. Okay, let me 8 and 9a. We are doing 8 and we have to do also 9a. Let's back to the exercise. So let's look. This is 8b2. Okay, we know that this satellite is geosynchronous. What does it mean? It means that the orbital period of this satellite is exactly the same as one Martian day. Okay? It's always above the same point on the surface. Is it clear? Like telecommunications satellite. So we know that time taken for Mars to revolve on its axis is 8.9 times 10 to the power of 4, which means that period of the satellite is 8.9 times 10 to the power of 4 seconds. And you have to find orbital speed of the satellite. So what is orbital speed? Orbital speed is 2 pi r over t. And we have r? No, we don't have r. We have constant k. Okay, so let's look. We can calculate r because in previous point you wrote that t squared is equal chi r to the power of 3. T is given 8.9 times 10 to the power of 4. K was calculated. Okay, 9 times 10 to the power of minus 13. Times r to the power of 3. So by using this equation you can calculate r, and then by using r and t you can calculate v. Okay? And c. The ratio distance of the Mars from the Sun to distance of the Earth from the Sun is 1.5. Show that the intensity of solar radiation on the orbit of Mars is about 600 watts. Okay, distance between Mars and Sun and distance between Earth and Sun is given as 1.5, and you have to find what is the intensity of solar radiation on the Mars. Here we have to use a solar constant. Solar constant is given in your data booklet. It's 1360 watts per square meter. So solar constant 1360 watts per square meter means that what is the intensity of sun's light at the position when Earth is located. So let's look. We have intensity due to the Earth. We have to find intensity due to the Mars. What is the relation between intensity and distance? Inverse square law of radiation. Intensity is proportional to 1 over squared distance. Is it clear? Okay, so let's look. We can write something like this. Intensity on the on the position of Mars to intensity on the position of Earth, which is given, yes, is exactly the same as 1 over distance to the Mars squared divided by 1 over distance to the Earth squared, which is distance to the Earth squared divided by distance to the Mars squared. The distance to the Mars over distance to the Earth is given, so you have to take this to the power of 2. Okay, finally obtaining that intensity on Mars, which is unknown, over intensity of Earth, which is equal to solar constant, is 1 over 1.5 to the power of 2, so 1 over 2.25. What does it mean? That intensity on Mars at the position of Mars is 1360 divided by 2.25, which I believe is around 600, because you must prove that this is a 600. Okay, determine in kelvins the mean surface temperature of Mars, assume that the Mars acts as a black body. Again, in your data booklet, in chapter 8, energy production, Where is chapter 8? Here. Okay, you have equation that power is emissivity constant, surface area t to the power of 4, and intensity is power over area. So you can write that intensity, which is power over area, is emissivity constant, temperature to the power of 4. Assume that Mars acts on like a black body, means that emissivity is equal to 1. So you have EI 600, which is equal sigma, is given in your data booklet, times 10 to the power of 4. By using this, you can calculate temperature at the surface of Mars. Okay, there's one more. Atmosphere of Mars is composed mainly of carbon dioxide and has a pressure less than 1%. Outline why the mean temperature of Earth is strongly affected by gases in its atmosphere, but the Mars is not. Okay, so you have to refer to the greenhouse effect. You have to describe what the greenhouse effect is. Sun has a radiation of wavelength such that the atmosphere is transparent. For this radiation, it heats up the surface of the planet. Surface of the planet is set up to certain temperature and re-emits this radiation of different wavelength, and this different wavelength corresponds with size of the carbon dioxide molecule, which is a greenhouse gas, which means that this radiation is absorbed by carbon dioxide molecule and re-emitted in all directions. Part of this radiation heats up the surface of the planet again, and now you have to refer to the amount. In the case of Earth, when the pressure is 100 times bigger, it means that the amount of particles is much more bigger than on the Mars. If amount of particles is much more bigger, then amount of carbon dioxide particles, greenhouse gas particles, is also bigger. So on the Earth, this absorption and re-emission in all directions, yes, is done by much more bigger amount of molecules, so the effect is significant. In the Mars, much less molecules, so effect is not significant. Something like that. Okay, so we did exercise number 8. So now exercise number 9. The question was about 9a. So this one, let me copy. Okay, and paste to new slide. Okay, so the last you've asked, so it will be the last I'm going to do. Remember, ask me, and on video lesson I can explain the best as I can. I didn't check mark schemes. I hope my answers are logical. No, are logical and correct. I don't calculate from the beginning to the end. I'm going to show a way only. I hope it's very, very useful. Okay, so exercise number 9a. A liquid oxygen as its boiling point is stored in an insulated tank. Gaseous oxygen is produced from the tank when required using an electrical heater placed in the liquid. The following data are available. We have mass of 1 mole of oxygen, which is 32 grams. We have specific latent heat of vaporization of oxygen, which is 2 to the 1 times 10 to the power of 5 joules per kilogram. And you have to distinguish between the internal energy of the oxygen at the boiling point when it is in its liquid phase and when it is in a gas phase. Okay, so let's look. We have two states, liquid and gas. We know that internal energy is the sum of kinetic energy of all molecules and potential energies of all molecules. Is it clear? During boiling, liquid has the same temperature as a vapor. Let's imagine a water. Water boils at 100 degrees Celsius. It means that both water, liquid, and steam, a gas, can exist at 100 degrees Celsius. So kinetic energy is the measure of the average kinetic energy of the particles in the substance, which means that if temperature is the same, then kinetic energy must be the same. So, for during boiling, for liquid oxygen and oxygen in the gas form, during boiling, kinetic energy is the same. So, there must be difference in potential energy. What is a molecular difference in the molecular structure of liquid and gas? in gas, molecules are much further than in the case of liquid. Is it clear? You cannot refer here to the ideal gas. Ideal gas cannot be liquefied. In this case, we have liquid oxygen. Is it clear? In real gas. So, back here, kinetic energy is the same, and a vapor has bigger potential energy between the molecules than gas. So potential than liquid. So potential energy of molecules of liquid is less than potential energy of molecules of vapor. What does it mean? That in the gas form, internal energy of the liquid of the oxygen, again, internal energy of the oxygen in gas form is bigger than internal energy of the oxygen in liquid form, because both have the same kinetic energy, but in the case of gas, potential energy is bigger for gas than for liquid, because distance between molecules is bigger. Okay, that's all. And how? Did you like it? I hope yes. I hope that I had you. I hope now that my answers are clear and you know how to solve rest. If you didn't try, please do this paper. And for next time, please focus on both my sessions. Yes, so I'm talking about 2018 my paper 2, time zone 1 and time zone 2. Let's train with these papers. Ask me if something will be not clear. I'm waiting for your questions. And of course, if you have some suggestions, write me in the form of the comment or post on Google Classroom. Okay? Remember, learn physics, stay at home, and see you next time. Bye.